Okay, another session of the Portland Python Pirates. My name is Chris Thompson. This is the second installment of our series on containers. So we're focusing on Docker. It's not the only runtime, but that's the most popular and probably the most useful to anybody here. This has been a really popular series, and containers are a really complicated thing. So if you were here last time and you felt totally lost, that's to be expected. I've been working with containers and Docker for that matter for like 5 years now, like straight. So it's taken a lot of repetition and just reading things. I've read the same thing over and over and over and over and over. Like I still find new things in the documentation and new things about containers all the time. So like wrap your head around this stuff, give it time. This stuff is complicated, but once you get it, you'll realize how powerful they are. And I'll kind of give you a little taste of what we're going to talk about. And we're doing kind of a mid-session, I call it, the dev containers. So it's an application of using containers in your everyday development. So that'll be next time and before we do Kubernetes. And I think that that'll hopefully solidify like why, how with containers a little bit. So definitely check that out if you haven't signed up already. So myself, I'm the main organizer, and then I also have a co-organizer, Brian Holman. I don't know if he's here right now, but you can visit our website, Portland Python Pirates, pythonpirates.org, and you can join our Slack channel. You can check out some resources. We're always trying to update it, so if you have any resources you think we should add, please let us know, and we will add them to the list. And then in Slack, you can reach out to either of us. We're happy to answer questions, but there's also like a couple hundred other people who are very willing to speak and answer questions as well. So if you have anything Docker related, I think I started a channel. Someone correct me if I'm wrong, but if I didn't, after this, I will start the container channel so that we can have conversations about containers, because there's just an endless supply of information, and I would like to learn new things as well. All right, guiding principles. We are inclusive. Everybody, all walks of life are welcome. We are Python focused, dabbling in other languages as needed, but we try to keep our focus on Python. We do progressive learning. So this series you can think of as a microcosm of that. We start with just a basic, what is a container? And we'll go all the way up to scaling and orchestrating containers and applications with Kubernetes. And we are collaborative. So if you have something cool to add or whatever, you can raise your hand or drop it in chat, and we'll all learn together. The agenda today, we're going to review Docker. Okay, so I just want to make sure that people remember, it's been a couple weeks, so we'll do a quick review of Docker, then go into why are we using Docker Compose, or why do we need Docker Compose, and then we'll do the demo. Funny meme I found. So with little hint, we do need Docker files still, even though we're using Docker Compose. The resources. So I'm also going to, and I meant to do this, I'm going to share these slides in the Notion templates so that you can have those. That will give you the access to these links, or you can just copy and paste them right now if you can't wait. So three kind of resources. I'm gonna put this book out there again. Docker Up and Running 3rd edition. I think it was just released like this month or something. So it's the very latest information from O'Reilly, well, it's not from O'Reilly, but Sean P. Kane wrote it, and it's just. And I think Carl Matthias, if I remember right, he might be with Cloud Gurus. I can't remember, but anyway. Really good book. This is how I first learned Docker. I had this sitting next to my desk at work as my hair was on fire and I was orchestrating containers, trying to learn as fast as possible and productionize machine learning models. It was terrifying. But this book helped me understand the nitty gritty. And with the updates, I'm sure it's even better now. Just a really, really great book that you should have as a reference. And then the documentation. Docker documentation is really, really good. I say that about a few projects. Not every project I talk about is great documentation, but Docker does a fantastic job with their explanations. It's all very well organized. So definitely check out the documentation. And then using Docker Compose with VS Code. This link actually takes you to the VS Code website. They have also really good documentation on utilizing Docker containers, Docker Compose. With VS Code, they have nice extensions that you can use. I won't be demoing those today, but I would recommend going to this link and exploring those on your own time. And we will be exploring more next week when we dip into dev containers. Dev containers are actually an extension of VS Code. So if you don't have VS Code and you want to like dive into dev containers, download VS Code before the meetup next time. All right, let's dive in. History of containers. So we talked about last time, going from bare metal all the way up to containers, and we talked about some pros and cons. So containers come after, well, they've been around for a really long time. The idea, and at least the technology that containers are based on, has been around a really long time. But it's only within the past, I mean, Docker really popularized containers, like kind of made them usable, more usable. But they use processes in C groups, or excuse me, namespaces in C groups for isolation and resource control. That's what they're based around, and those are very, very old. Been a part of the Linux kernel forever. But when we talk about pros and cons, the pros of containers, you can have multiple versions of libraries in a single operating system, right? And so what I mean by that is containers are really lightweight, so we can spin up a bunch of containers, and each one can have different dependencies installed inside of the container, versus say like a VM, right? So doing isolation of dependencies, multiple dependencies on a VM, well, that's not as straightforward, right? With containers, we just spin off a container. Oh, I want Python 3.8 instead of 3.7 now. Perfect. It's fine, right? It's isolated, and it still uses the host, utilizes the host resources, just like a VM. Oh, sorry, I'm like pointing at the wrong thing. The host resources versus a VM, but again, they're lighter weight, and you get those different binaries and libraries as needed. So lower resource utilization, we talked about portability and scalability. So portability, meaning because they're lightweight, because they are, generally, right, like very, don't take up a lot of storage. You can move these around. I mean, you can deploy containers. Containers are used at the edge where there's like, you're dealing in megabytes, right? All the way to, scaling up. Sometimes containers can be really heavy duty. I've seen gigs, multiple gigs for containers. So, but nevertheless, still lighter weight than say it would be to ship a virtual machine. And then scalable, so they can spin up much, much faster than a virtual machine, which means you can react to events faster, such as increases and decreases in traffic. And they come up and spin down, and because of that, you can really kind of be effective in cost management, and resource utilization. So, and we just mentioned faster boot times. Cons: possible increased complexity, right? And I say possible because it depends on the application and what you're using them for. But once we start talking about Kubernetes, and even today, you're going to start to see that, like, as we think about scaling an application, maybe breaking an application down into microservices, you start to see, networking becomes an issue, and there's lots of other things. Storage becomes something you really need to think through, and those types of things. So we'll look at that today. Increased costs due to complexity, right? So like we said, they can be cheaper, but that's assuming that you have a knowledgeable staff of DevOps engineers or whoever who know how to manage containers, in terms of like say Kubernetes or something to that effect, right? But as complexity increases, right, you have to pay these people to manage these systems, and that can increase costs, as well as as your application grows, you're utilizing more resources. That can increase complexity, and usually we're talking about cloud resources, right? Like there are obviously instances of companies using Kubernetes locally, right, or containers, but the costs, especially the increases in costs, really hurt you in the cloud if you're not careful. So, and then monitoring becomes more difficult. So as your containers, if you have 1 or 2 containers running, as we'll see today, right, we can just kind of stare at the logs and we understand what's going on. But if you have hundreds or thousands of containers, right, that's a little more difficult, right? So monitoring can definitely be a challenge when it comes to containers. All right, so we use containers. You know, it allows for these smaller architectures, these micro, you know, the buzzword microservice architectures. You know, in general, I just say like smaller services, right? Right, easy to scale and allow for isolated features. What I mean by isolated features, and we'll go over this more today, is like if I have a dev team, right? And actually, I mentioned it down here. So let's keep going, and I'll mention that in a second. So portability, we already mentioned that. Containers ensure develop once, run everywhere. Because it's isolated, it is indifferent to the host that it is running on. As long as the host has a container runtime that's able to run containers, run it anywhere, right? Better collaboration between teams. So I can share, and that's part of why we're going to look at dev containers. We can look at a way to use containers to collaborate on a team of developers and share environments with dependencies already installed, and that ensures that we have consistency in our dependencies and make sure that no weirdo bugs happen between, say, like Mac and Windows or something to that effect. And then more consistent QA and production environments. So just as between teams, right, I share a container with another team and they can just run it and it's all good. Also between environments, right? So testing, production, all of that, we just move containers over, which I've done in the past. It works beautifully, right? And while we watched you know, and obviously they had a bigger application, so it's not a one-to-one comparison, but I've been in deployments where they've done, say, 6 to 10 hour deployments, but once we switch to containers or utilize containers, you know, we're done in 20 minutes to a half an hour tops, you know, and that's really vetting and making sure everything's running correctly. But really, it can be measured in, you know, a couple of minutes if containers are just spinning up and down, which leads to CI/CD, which we're not going to talk about today, but that's kind of what drives CI/CD, is like containers and so forth. Team agility, so allows developers to focus on individual features rather than the application as a whole. So as we'll see today, when we break down the application, what I've done is the application last time we loaded it up into a single container. We're going to break down that application into multiple containers today, and we'll see how a developer could just work on one single part, right, a feature of the application, and is indifferent to what's happening in other parts of the application, you know, and they interact through an API interface using HTTP protocols, much nicer in terms of developing. So that leads to faster development and deployment and quicker ROI than with monolithic applications, right? We don't have to wait for all the features to be done to ship an application. We can just deploy that container, that piece of the application, that feature that we were working on. And as long as the contract, right, is the same between whatever services we're relying on that container or whatever that services that container is relying on, we can just ship it individually, which allows us to work on different development cycles and can really accelerate, like it says here. We can realize faster ROI. So an example would be reacting to users' requests for a feature. Right, we can deploy that feature without disrupting, well, hopefully without disrupting other services. Caveats to that, but overall true in general. Okay, any questions or comments before I move on to, or keep going? That was a lot of information. Maybe go back. Okay, cool. All right, stick with me. So what is Docker, right? Well, we have containers, right? We've defined them as isolated processes utilizing host resources through utilizing, you know, using C groups, right? And namespaces and so forth. Well, okay, so, but what is Docker? So Docker is a nice tool. It's a container runtime. And this tool automates the building and running of applications in containers. So containers are cool, but they would be complex to manage just on their own. So that's what Docker does for us, right? So it uses a client server architecture where we direct commands such as Docker build, Docker pull, Docker run. We communicate with the Docker daemon or Docker host, but the Docker daemon, and the Docker daemon then goes off and does the thing that we say. So build, right? It'll build this here an Ubuntu image, right? And then we say Docker pull. That should probably be before, but anyway, we could Docker pull an Ubuntu image, right? And it would pull from, well, this leads to here. Oh, they're pulling an Nginx, I see. So you say Docker pull, pulls an Nginx container down to your system. So now you have two images on your system. You've built a custom Ubuntu image. You've pulled down just a standard vanilla Nginx container. And then you can say Docker run, and then Docker run will run container instances of those images. So similar to how you have VM images, that's how I think of container images. They're just pre-built and ready to be spun up at a moment's notice in a container instance. So containers are running instances of container images. Okay, that's great. So Docker makes our lives easier. We're using containers. We're superstars. Everybody loves us. But so why do we need Docker Compose? Well, Docker Compose, right, is something that allows us to run multi-container applications. Okay, so last time we had one container, right? And that container was bound to ports on the host system. It was utilizing the host network, right? Local host, and everything was great. But what if we have like 3 containers, which we'll see in a second, foreshadowing. What if we have 3 containers and we need those containers to talk to each other, and we only really need to communicate with one of those containers, and we don't want them all running on the host network because maybe that's a security hole or a security concern, and so on and so forth. So how would we do that just using Docker? Well, we kind of could, right? But we'd all be on the host network, and there's no real way for isolation and coordinating containers without a lot of overhead, right? So that's what Docker Compose does for us. It simplifies the process of running multiple containers that are part of a single application or that need to communicate with each other, right? Without us having to define those rules, right? Those networking rules. And so in say like IP tables. And so multiple isolated environments on a single host, right? So we can create multiple copies of a single environment for each feature branch. What does that mean? Well, if I have a dev, right, test and prod environment, and let me make this more accessible. I was developing an application, a machine learning application, where we were doesn't really matter what we were doing, but we were trying to make predictions, right? But the entire application was made up of a total of 6 containers, right? And so, but we also had 3 environments. So they were networked in such a way that the development team, right, we had an integration environment with them where we would test back and forth with the front end. Then we needed to move it to a staging environment where QA could click around and make sure that everything looked correct, right? Do smoke tests and so forth. And then we had a production environment, which was actually a separate server where we needed the application was actually interacting with end users. And so we had used Docker Compose. We had our 6 containers. We had our development environment where we developed those 6 containers. We would then move those to the integration environment. We would just copy it over, right? But utilizing Git best practices. So we push the code up to Git. It comes down into our integration environment. We do our integration, push it back up. It moves it over to staging and then on to our production environment. And all of these, right, we always move forward. And all of these were the exact copies, right, of that environment. So like we could duplicate this environment very, very easily, right? Just by copying files, moving files around. And so what's really powerful about that is we can do something called git ops. And git ops is something you'll hear a lot with containers. And what that means is we can declaratively define how our applications look, keep our declarative files in terms of Docker Compose. We can keep those with our code and version control those along with our code so that a single commit cache is associated with those files, right? And so version control, we version control our environments that way through files, which is really, really powerful. So then we can deploy it wherever we need to based on a Git hash. Right, it allows for tracking. So when you think Git ops, it's a declarative way of moving environments, right, from one place to another. And this is also done with Kubernetes. You can literally just move a Kubernetes cluster through files from one location to another. So if you have two servers, a production and a development, and you have a cluster on production, you have a cluster on development, well, you don't need to actually like copy the entire server over, right? You just move some files via Git, pull it down into the production server, apply it, and it launches, right? So this is really nice. When you get it right, oh man, it is super nice. So anyway, that was a bit of a tangent. If you didn't follow that totally, no worries. I was just trying to give a kind of tangible example. We'll get deeper. I think Docker Compose will seem we'll see it in a minute, and it'll make more sense. Keeps build from interfering with each other on a CI server. So that's what I meant, right? Like you're just moving environments via files, right, declaratively, and they don't interfere with each other because they're version controlled and associated with hashes. So there's no like hash collision in terms of commits. I see a question. Wing Lai?
Chris, could you tell me that what is QA? What is CI server?
Oh yeah, so sometimes when you're doing continuous integration, getting resources from anywhere and also not starved for resources by any other process. So that, you might have a dedicated VM or even a bare metal server that you use specifically just for your continuous integration. Does that make sense? Answer your question.
Yeah. Did you tell us that QA is a person or something? Do you know?
It looks like you're muted, Chris.
Oh dang! How'd I get muted? Weird. Oh. Did you not hear the answer to my question? I apologize.
No, I didn't hear very clearly. Could you repeat that, please?
Yeah. So I just put on my headphones too, so hopefully that helps. So a CI server would be a dedicated server that you're using for your CI processes. And it's so that you're not starving any other processes for resources. And also so other processes don't starve your CI process for resources. So there's no like interference, at least as far as I understand it. Maybe there's other benefits, but also isolation, and you can probably, networking and stuff, it's less of a headache, that kind of thing. Because oftentimes I think intuitively for me, like a CI server has access or speaks to multiple environments. So you want to be careful what has access to that environment. So isolating that makes it easier, right, to configure networking in such a way that you don't have some sort of security vulnerability or something like that.
Okay, thank you. I got this one. Earlier you have a two capitals QA. QA is a person or something? Or is it...
Let's see. Earlier I had, let's see, where this one?
I think he means quality assurance.
Oh. Yeah,
this one?
Yeah. Consistent QA. Okay.
Yeah. QA is quality assurance. So like a testing environment, right?
Okay. Thank you.
Yes. And thank you for whoever verified that. Okay. So as I was talking, in my example, I only had 2 servers, right? So what I was actually doing was utilizing different ports on the servers for those environments. So the Docker Compose environments had no idea that each other existed on there because of how I configured the networking, right? But so we can have actually multiple Docker Compose environments, just as we can have multiple containers in Docker Compose, we can have multiple Docker Compose environments running on a single server. And so that saved us a lot in that. That was a long time ago, and maybe I do it differently now, but I felt pretty good about it at the time. So okay, we can preserve data in volumes. So software-defined storage, right? It just cordons off from your hard drive, some storage, and you're able to utilize these software-defined volumes that can then be attached to multiple containers, whoever needs access to that data. And we'll kind of see that today, although I used the database, but you could have used volumes. We only rebuild and recreate containers that have changed. So it actually caches and understands, kind of how we talked about how Docker containers cache and understand that what's changed and what hasn't through hashes of each layer of a container. It does that for multiple containers. So let's say I need to bring up just one container change, right? When I move that and do a Docker up, right? All of that information is cached. And so it'll only rebuild or recreate containers that have actually changed in the environment. So if we have 2 containers that make up our application, but we only worked on one feature, it'll just hot swap that container out with very little interruption, right? Which is really, really nice because you don't have to like bring down the entire, there's no downtime in terms of updating an application Docker Compose environment. I know this is abstract. We need to get to the demo so your heads don't explode. So you can use them for development environments, automate testing environments. We just talked about that. I guess the slide gets a little redundant, huh? Okay, so what I wanted to show you before we jump in, this is a very simple diagram of what we're going to be looking at. Okay, so what I've done is here's my host, aka my laptop, right? And we have an ETH0, right, interface, and our networking interface, ETH0. If you do an IP config or an IF config, I forget which one's which for Windows and Mac, but you'll figure it out. If you run that, you'll see ETH0 listed, right? And that's your local interface. And so that local interface will actually connect to our Docker Compose environment. So each of these green things, I should have a key. This is terrible. I need to redo this. But anyway, the green represents a container. So we're going to have a predict container, a pre-processing container, and a Postgres container. We've defined some networks. So there'll be a back-end network represented by this blue, and there'll be a front-end network represented by this yellow. The pre-process container is actually part of both networks. And we'll show that in a minute. The Postgres container only lives on the back end, and the predict container only lives on the front end. Why do we care about that? Well, we care about that because predict, right? What we've done is using virtual networks, we've isolated our containers. So like, and really these lines, they're going to the wrong place. Anyway, you'll see. The point is that predict can't talk to Postgres. Only pre-process can talk to Postgres. So predict actually only interacts with pre-process. Vice versa, if someone gained access to our Postgres, they can't get into the predict container. And so you get this kind of like nice isolation, right? And there's much more complex networking schemes that you can do with this. You can connect to actual networks, right? And put containers as if they're nodes in a network and all of this stuff. It gets really fancy. And for more information on that, you can check out the Docker documentation. But we're going to deal with this very simple way of doing it. And I'll show you how to create these. It's actually not as complex as you might think. So get ready. It's time to do a demo. Let me set this up. All right, here we go. Can everybody see my screen? I just want to make sure before I go rambling on. Great, got a thumbs up, sweet. Okay, so the actual repository, anyway, will not have a Docker Compose and a requirements file. So that's going to be on you right, to use the Notion template to create those. And then there's a walkthrough and an explanation of the entire thing in there, right? So no worries if you don't completely follow what I'm saying today, the Notion template will be your guide. And while I'm thinking about it, let me share that again. I will be adding that to the README afterwards, but I'll drop it here just in case you want to check it out right now. So you can see here our file structure looks a little bit different. We have a CSV directory, we have a predict directory, and we have a preprocess. Now, if you recall, what our application is doing is taking in data and making predictions. We can call the data features in machine learning terms, right? It's taking in some features. In this case, it's temperature data, right? And making predictions based on those features. So what I did was instead, we had one container last time, right? That did everything. Well, this time I've broken it out. So we have a predict container, and I'll jump in there really quick and just show you. We have some caching that we've done here. So this is the container that we'll be interacting with. And it has a predict endpoint, a post endpoint that does predictions, and it gets a prediction, and it forecasts based on a window provided. I've also added a city. Now, I only have Raleigh data in here, but why I wanted to do this was to leave it up to you. If you'd like, you can go grab this temperature data. I believe this was from NOAA, right? You can grab this more temperature data for another city, pop it into this directory, and we have a script that will load it into the database. And then you can come into here, not here, into the config. Where is it? Hold on, it's somewhere. So we can add more temp paths, and this will give you a little more an option. You don't have to do this, by the way. If you just want to do containers and you don't care about fast API, that's fine. But this is kind of like, I left it a little bare bones so that you can, we have an unused package, that you can come in here and mess around and try to add more temperature data, right? And as we feed in a city into our main, right, it extracts the city, and then we load it up in preprocess and so on and so forth. So if you'd like to know more about that, I'd be happy to jump on an intermediate call with folks to show them an update on this. I just didn't want to focus on that, but maybe in the future we can update this. But if anybody wants a fun project, go in here, read the code. I commented as much as possible. Read the code and figure out kind of what it's doing and see if you can add another city. Again, right now we have Raleigh, but it is fairly straightforward to add more. You'll just have to actually dig in and figure out the code. So I look forward to somebody solving that. And maybe there'll be a prize for the first person that shows me that they've done that. Okay, anyway, so we have this fast API application. So the first container is going to be our predict container. So this is the application here. Here's our Docker file that will spin up our predict container. The second one is preprocess. So I've included the application code in here. We also have a Docker file. Notice I said .preprocess. I like to append a suffix to my Docker files when there's multiple Docker files living in the same like repo. I don't even care if they're in a different directory. I just don't like the idea of files being named the same thing in the same like repo. That just, I've seen people do it that way where they just call it Docker file. And I'm like, like just to be safe, let's make sure we put some separation there. And it's arbitrary. You can call it dockerfile.awesomeness, right? It doesn't matter. It's an arbitrary name, but like by doing that, you can just, you don't get too confused, right? So it's basically the same thing. It's just spinning up this application instead, right? So these Docker files are actually more or less like identical. It's just they're doing different things. So anyway, spinning up different applications. The only thing that's like really different is like that line. Okay, so we've got our predict, we've got a preprocess, and the preprocess is, let me just show you that main file. So this is a little different. There is an endpoint. It's a preprocess endpoint, but it only accepts requests from it's going to only accept requests from predict, like we saw in that networking diagram. right? So this will be isolated. And I'll show you the Docker Compose file in a second. We also have an init SQL script. So this will automate, and I'll show you how we do that. We automate the loading of our data into our database. And you're like, well, cool, Chris, where's the database? Let's look at our Docker Compose file. I will show you now. All right, so we have, when we do a Docker Compose is in YAML, right? So this is under the covers. YAML is actually just JSON, but this is kind of like, in my opinion, like people hate on YAML, but I'm like, do you really hate YAML more than JSON? like a massive nested JSON object. It's like, pick your poison, but like finding missing curly brackets is like the worst thing in the world. So like, I don't know, YAML, I'm cool with it. Like I like it. I like YAML. Anyway, but note that YAML and JSON are like interchangeable. So like you can actually like, there's tricky things you can do where you represent it as YAML, but then load it as JSON and it's fine. And like, it's pretty cool. Anyway, so what we do is we define some services. So services are different, you can think of them as the different containers that we're going to be running. Okay, so here we have 3. The first one we're running is a Postgres container. This is a vanilla Postgres container. So when I say run this, Docker Compose is going to look locally first. It's going to look for Postgres. I have it, so it's going to be fast for me. But when you first do it, it's actually going to download it, okay, into onto your computer. The Postgres image from the Docker Hub repository or Docker Hub registry. Yes, registry. So it's a public image available, kept up by the good folks at Postgres and or whatever the company is. So I give it a human readable name. This is going to be my local name for it. So I call it Postgres because I don't have any imagination. And then environment variables. So you can define it external environment variables, right? When this container runs. So in this case, this is pretty standard. These come shipped. These are the user, password, and database name that come kind of with the container. If we wanted something different, we could change this, but that gets into creating secrets and so on and so forth. And I didn't really want to do that this time. But I also could challenge you to go figure out how to better encrypt these things, because they should not live in plain text in your Docker Compose file. Go figure out how to encrypt those or make them better, right? And there's actually a hint. There's a link in the Notion template that will lead to one example of how you could do that. So check that out. So we have some volumes, just like we had Docker volumes last time where we mounted directories to our containers. We can also do that in Docker Compose. So here we're mounting our local CSV file, which was this one here. This is the data. We're mounting that into var lib PostgreSQL CSVs. Okay, and this is kind of, the PostgreSQL is just a place where you can like load things that SQL needs to know about. I think I also dropped a link for kind of what this is all about. I'm not going to go deep into why we've done this, but essentially what we're doing is we're mounting the data so that we can load it using this init SQL script into our database. And so if you look at the init SQL script, you'll notice var lib PostgreSQL, and then Raleigh temps.csv is what we're loading in using this query here. Where were we? We're on Docker Compose. Okay, so, and that's that. And this entry point, this is where you put an initial script. And again, check out that link in the Notion template. It should be underneath the Create Docker Compose file section, and you'll see a link for that. Okay, so we also we say expose, but if you remember when we talked about Docker last time, expose is more so for documentation than it is for, oh wait, is it in this case? Ooh, I should have thought about that. In Docker, so we talked about last time, in Docker files, when you use expose, so if we go to like this Docker file, for instance, and it says expose 8000, that's not actually doing anything. It's just kind of documenting within here that that's the port that you should expose if you are to run this container. In Docker Compose, I can't remember now, and that's so bad of me. I'm pretty sure expose in Docker Compose actually exposes the port 5432. right, on Postgres, which is the standard port for this container. Now note, this does not bind this port to your host system, right? This is just exposing the port for the container, and we are going to run this on the back-end network. So only other containers running on the back-end network will actually be able to communicate with this container on port 5432. So on our host system, if we start this up and we try to ping this, we won't actually be able to access it. Okay, and that's good. That's a good thing. We don't want to access it. That gives us that isolation. Okay. Any questions on that? I know this is starting to get in the weeds a little bit, so please, if you have any questions, let me know. Okay. Keep going. Here's our predict container. Oh, I heard someone jump on mic.
I just have a question.
Mm-hmm.
So, so you said the where mounting the where folder for data. So when we do the production, right? So it'll be the same where, or it'll be in a different location, or this will be in the same disk. How you can, make it more decoupling that?
Yeah, it's such a good question. So it's of course my answer is it depends. but in general, right? Let's say you're in the cloud and you're running on, right, a VM. Well, we have disks that we can attach and mount to that VM at a certain directory location. So potentially what you could do is you could mount that disk with whatever data or whatever's on there, mount it at a specific location on /mount/CSVs or something like that, and then mount it to this container. And so again, the way that you architect your storage is really going to depend on your use case. But there's also ways that you can, I know in Kubernetes you can do it. You can mount storage buckets as well. I don't know if that's possible with Docker Compose. I've never done it before. But if you can mount a storage bucket, say to a VM or something like that as a disk, which I also don't know is possible. Never really done it. But I've done it in Kubernetes, mounting it. So I think that there's possibly a way, but I'm not sure if it was just Kubernetes doing that or not. But anyway, however you can mount it, this is a local, right, directory. But if you say mounted it to a local directory and /mount, then you're actually mounting the disk to this container running inside of that VM. That was kind of rambly. Did that make sense or answer your question? Cool.
Yeah.
Okay, cool. Yeah. Wes, yeah.
Yeah, I was wondering, up at the top where it says version 3.9, that's not talking about the Postgres image. Is that what is that related to? Is that a Docker version?
Great question. Yeah, that is the Docker Compose version.
Okay.
So there's the syntax of the Docker Compose file has changed over the years. They add features, whatever, right? So yeah, that's the version of Docker Compose.
Makes sense. Okay, thank you.
You're welcome. Cool, good questions. Okay, so that's our database, and I'm not advocating, by the way, using PostgreSQL like databases as containers necessarily. I don't think that you'd have to give me a good reason why you'd be doing that. I'm doing it here for effect, right, and demonstration. It is cool if you, well, I'll get to it. Let's finish what we're doing, and then I'll tell you why maybe you might want to do that. Okay, a use case where you would do that. So we have our predict container down here. Note that these names here are actually the host names that get assigned to these containers. So our Postgres container, if we want to communicate with that through, remember, our preprocess container can communicate with our Postgres. If we want it to communicate, actually internally, if you look at the code, let me see if I can go back here. we look at the code in our preprocess container app service. Makes a call somewhere around here. It's in read temps. Sorry, give me 1 sec. I'm just gonna try and find it. Somewhere around here. Well, anyway. Oh, it might be in our .env. Let me see. Oh, I forgot to add the .env. Should probably add that to the Notion template. Might break. Anyway, somewhere in here, I think it's in data cleaner, like where it actually calls the data. Anyway, it calls it by, the whole point of what I'm saying here is just that it calls it by the host name Postgres. So when it's referring to the Postgres container from the other container, that's actually the host name that you can call it by on that network. So on this backend network, Postgres will be Postgres, preprocess will be preprocess, and those are defined by what you give here as a name for the service, not to be confused with the container name, which is how we actually see it in logs and different things like that when, or if we want to exec into the container for debugging, right, we use this. But I called it this. This can get a little confusing. This is out of habit. I try to keep things consistent because when it's named all kinds of different weird things, like it can get, I think that gets more confusing. So I just name it the same thing everywhere so I don't have to remember it. I don't know if that's best practice. That's just what I do.
Hey, Chris.
Yes.
Are we in branch 2? Sorry, branch session 2.
Can you repeat that? You broke up a little bit there.
Yeah, sure. Are we in branch session 2?
Oh, yes. Thank you. Yes. I'm sorry. Yes. So I checked out section 2, the branch section 2. Yes.
Okay. And did you add new files to that pre-process folder after session 1? Like I cloned the directory, but like it's,
Yeah. So I may have been, I've been in here like fiddling around. So just do a poll to make sure you have the latest changes. Yeah.
Okay. Thank you.
You're welcome. And I think I failed to add this .env that you need to create this, but I'll add this to the Notion template after this. So I'll add the slides, I'll add this, there's a bunch of stuff. I'll add the link to the Notion template to the README. Those are my three tasks so far. Hopefully there's not any more. Okay. Okay, where were we? Right, container name, host name. Okay, right. So we're actually gonna build. Now you don't actually, there's two ways you can go about this. I have it set here just for education purposes to show that you can do it, right? So we can specify build from a Docker file. We give it the path relative to the Docker compose. So we say our Docker file lives in predict. It's called dockerfile.predict, right? And we give it a tag 0.1.0. That's the version number, right? And it'll build it for us when we spin this up. Now that's not necessarily what you want to do. Oftentimes when you're developing, you'll already have a Docker image specified. So it would be, whatever you tag it as, but like here with Postgres, you do the same thing for your predict containers. You probably have this already pre-built. You wouldn't be building it every time you fire up Docker Compose. So you would have this pre-built and you would just give it the image name like this. You would say image, right? Predict, colon 0.1.0 instead. Okay, I'm just showing that you can build things here and so you can iterate if you want and all that kind of stuff. But oh, yes, I wanted to note one other thing here, and I did this on purpose as well. Notice that we're using a command, and it's unicorn app main app host 000. Oh, let's see if I did it first before I get into it. Yes, okay, cool. So each of these Docker containers could be run on their own, although they probably won't work because they need each other to run. But what you could do is instead of having this command like this, you could have an entry point, right? And so what is an entry point? An entry point is so say I'm running, we go back here, I'm running this command, unicorn app main app, whatever. Here, instead of this line, I could say entry point, right? And then I could say Python 3. sorry, dash. We need comma dash n. Not app.main. Sorry, that's GitHub Copilot. Amazing, you should get it, but we don't need it to do that right now. So inside here, right, instead of saying the exact command that needs to get run when this container runs, you could give it an entry point. What that allows us to do is actually feed in arguments as if it was a command line script, as if we were running this as a script. So let me think of an example. So if you've ever used argparse, right, and you've created command line scripts utilizing Python, you have flags that you can put at the end, right? If you set your entry point to be Python 3 and then your script that you want to run, you can actually say Docker run my script, which is the container, but actually just put flags that your script accepts at the end of that Docker run command. So it feeds it into standard inside the container. So entry point is kind of used for that. In this case, we're not utilizing that, but this is another option where it kind of says you can only do things with Python 3 from outside the container. And then you wouldn't, I don't know if you'd use command, you'd probably use, maybe you would. But anyway, just a note here. So what actually happens is Docker Compose is going to overwrite the command running in the Docker file. In this case, they're the same, and that's not on purpose. That's probably me, just like an oversight by me. But just know that that's the case. So we specify the command here. You want to put as much as you can into your Docker Compose file, just from a development standpoint. Put as much as you can into that Docker Compose file. And the reason you do that is just so what I'm doing right now, you don't have to keep going back to the Docker files, right? Every time you want to know, oh, what command is running in here? Oh, what port is exposed? Oh, like all of that's available through Docker Compose. So try to put as much of that here as possible so you don't have to context switch back and forth to see what the heck's going on, right? So I tried to do that here. So we see that command, uvicorn, oh God. Uvicorn, which is our web server, our Python web server. We are running our application and it's broadcasting on all ports inside the container. But what we've done is we've bound our host port 8000 to our internal port 8000. So we will be actually, by using this ports instead of expose, this container will be available to us on localhost 8000. Let me say that again. So here we exposed the port 5432 on the backend network, but only containers running on the backend network can actually access this. Here, we've actually bound it to a host port on our local system, which gives us access to this container via localhost. Okay, so the difference between ports and expose, two different ways to do it. We also bound this to a front-end network, and we also gave it this, this depends on. Now, this is not a health check. If this Postgres container comes up, which you should add, by the way, I didn't do it here, but health checks are something you can do. So you can, before this container is actually live, right, as it's spinning up, you can define health checks that will check whether this container is in fact healthy, not just up, but actually doing what it's supposed to be doing. So those can be bash scripts or whatever, right? But health checks are a great thing to define, right? And then if you have a health check, you know that say we did a health check for Postgres container, right? Then we know that this container is up and healthy. Then we can say this container depends on Postgres being up. And because we have a health check, we know it's also healthy. And therefore, so basically what happens is this container will not spin up until this container is up and running. And we use depends on to make sure of that. So it's kind of an order of operations in terms of things spinning up. Plus, right, it does depend on our database being live because this is where our data is. So no data, no API, right? So anyway, it'll fail if this fails, which is kind of nice. It gives us some power over how these are spun up in what order, like an order of operations, like I said. Last containers preprocess, it's basically exactly the same as our predict. We are using an N file. I did that just like, this is kind of whatever, but I did it just so you can show that you don't need to always feed it in as a variable. You feed it through a file, right? So that's nice. We define 2 networks. So notice, remember, this is the container straddling both networks. And we also have the depends on Postgres because no data, no application. Doesn't matter, right? So fail before if the database fails. And then this is how we define our networks. Look how easy. We say networks. We say the backend network. So this is the name. This is the that refers to this, right? The network. So when we say backend, we actually are referring to this. The name is just a human readable name that we can use to access the network. Same with front end. Front end, that's the actual name of the network as the container will see it. This is an arbitrary name that I gave it, even though it's the same, so that we can see, like in the logs or when we list our networks, we can see, oh, it's front end network, instead of like whatever. It gives it some random name like Rousey Ronda or something, whatever. I don't know. I don't know why I said that. I don't know where that came from. But anyway, you know, it assigns random names if you don't give it human readable names. So I like to control the naming conventions of my things. Are there any other questions on that before we spin up this sweet application and take a look at it? All right, let's do it. So this is the command, right? Before we had like, when we had a single Docker container, we were like Docker run, do this thing, then the ports, then the thing. Here, notice that we've gone from an imperative. Okay, so some terms, hope maybe you know them, maybe you don't, but the difference between an imperative command, which is something you would type into the command line, versus a declarative style where we tell it, we give it this YAML file, instructions on how it should look, and then we leave it up to Docker Compose to actually do all of that, right? Why we like this? That goes back to version control. We know that if we I know that when I give this repo to you, this, with all of this defined, this will spin up the same way for you that it does for me, regardless of whatever system you're running on, as long as you have Docker. And that's really nice. I don't want to have to give you like a command line script to run, right? I prefer a declarative style. If I need to, I will, but in this case, it allows us a declarative style of creating our applications. And all we say is Docker Compose up. Docker Compose up, when you put that command, will look in the current working directory, right? In this case, we're in this base directory. It will look automatically for a docker-compose.yaml. You can, just like with the Docker command, just like with the Docker command, you could say Docker Compose-F and say like fancy, you know, compose.fluffy, right? If we had that file name, if that was the name of our Docker Compose file, we could name it that, but we have to tell it that it's not called Docker Compose.yaml. Otherwise, it automatically looks for Docker Compose.yaml if you don't specify a name, all right? So we say Docker Compose up. It spins up our Postgres, it spins up our predict, it spins up our pre-process. It's attaching all of our, it's creating all of our resources for us that we've defined declaratively within our template, right? Allegedly, it's doing that. We'll see if that actually works. Oh, I know why it's not gonna work. I already had it running in a different, hold on. Whoopsie. All right. Kind of anticlimactic. All right, let's try it one more time. Okay, Docker Compose up, creates our resources. We see logs get spit out here, right? So here we can see these Postgres logs, skipping initialization, blah, 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 blah. You actually ran our loading script when it went through its thing. Notice that then pre-process and predict come afterwards, right? After Postgres is all the way complete, right? That depends on working for us. Then we get our spinning up of our containers, and we can see here our application successfully came up in pre-process. Our application successfully is running in our predict. Cool. Now you're like, oh, that's kind of hideous. There's 2 other ways to do this. You can actually have the Docker extension, and you can look at things through here, which is really, really nice. You can, what equates to SSHing into a container from here. you can look at files inside of containers, so you can actually navigate the file system, right? And if we go to our opt folder where I put our application, we can see that our app lives in here, right? So the Docker extension is really nice for debugging. If you need to like see where things are living and all that stuff. Otherwise, you have to like run commands like docker ssh, or sorry, docker exec, and you have to like define a shell and like all this stuff. Instead, you can just navigate here, which is super cool, right? So I can navigate that file system. I can navigate this file system. Oh, that's Kubernetes. Oh, no, that's right. Okay, these are correct. Sorry, Kubernetes threw me off. I was like, wait, am I in Kubernetes? That's just the name of our tutorial. So anyway, so the Docker extension can be really useful if you want to stay in your IDE. These are some other ones I'm working on, and you can see your images here that are created. So notice I have a billion images on my, actually it's not that much, but I have a lot. It comes from Kubeflow and other things, MLflow and stuff. So I have several, quite a few. You can see the 0.1 container, right, is here. We can see our Docker Kubernetes series predict containers right here. We can see our pre-process containers right here, and it'll show you the different versions that you have. So this has the latest tag, but maybe it has, and there should be one more. Our Postgres is somewhere in here, probably alphabetical order. Here it is, right? Our Postgres, the latest, right? Pulled 14 days ago. So anyway, if you want to interact with Docker and you want to stay in your IDE, get the Docker extension. You can also see our networks. Check out our networks. Here's our backend. Here's our front end, right? Here's our bridge network, which is actually like what our host. That's what allows us to access Docker containers via our host network. And so, oh, sorry, here's our host. This is just a bridge network, random bridge network. But this is a bridge network, by the way. Anyway, I won't get into the networking pieces. And then our volumes. These random hashes are actually our volumes that were created when we mounted those directories. It sees them as volumes. If you don't want to do that, you can actually open up this dashboard. So go to your Docker desktop, go to dashboard, and you can see the exact same thing in here. That's not right. That's LensML. My bad. Okay, here. Postgres, predict, preprocess. We can click on any of those, go in, see the logs. There is extensions you can get. So I have a logs explorer that I use, and that puts the logs in a nice, colorful little log catcher situation here, like a GUI, or not GUI, what am I trying to say? UI. And this is a really nice way to view the logs, I think. Because it used to be, I used to just like output the logs to standard out in a shell, and it was like the ugliest thing I've ever seen in my life. So when I got this, I was like, whoa, this is really pretty. So Docker extensions, by the way, are something that was released fairly recently within the past year. And they're both produced by Docker and other companies, and they have all sorts of functionality associated with them. So if you want to see some cool things that you can do with Docker Desktop, check out Docker extensions. But Logs Explorer is definitely one I would recommend if you want to use the dashboard. I kind of switch back and forth depending on how I feel that day. Sometimes I'm in here, sometimes I'm in Docker dashboard, desktop dashboard. Oh, maybe we should like actually see our let's see. We'll go to localhost. So we'll go to localhost 8000. Here's our application running. See our predict, right? You can go in here, you can click it. By the way, this documentation is automatically created for us. Within our main .py, you'll see that I've like kind of put these, get prediction and like added some commenting and stuff. So you can control that from the Python code, but nevertheless, we see that. And then you see here, we have this extra parameter, like I said. So if you want to go and try to figure out how to add another city, highly recommend you do that to get more familiar with Fast API. Right now, all we have is Raleigh. And we'll do a window of 30 days and we'll execute that. This takes a little while. I'm not entirely sure why, but I don't want to debug it. Oh, no, it worked pretty fast that time. Okay, And you see here, here's our predictions. This is actually, you can load this into a data frame. This is like a data frame, pandas data frame. And then you'll note also that we could take this curl command that's shown here, right? You can click this little button here. This copies it to your clipboard. We can go back to our IDE. There it is. And we'll open up a second terminal here. Someday we'll open up the second terminal. There we go. And we can paste that curl command and also hit our API that way, which will output the same exact, yeah, it's deterministic. So same exact thing. Here's our prediction, our data frame. And we can, create an application that maybe sucks in that data and maybe creates a graph or something like that. But nevertheless, that's our Docker Compose application. So now, just to recap, right? That's kind of the end of the demo. So what we've done is, instead of last time where we had our, and let me just I'll discard this, delete forever, discard this, discard this, delete forever. Okay, cool. Some changes. Okay, I just pushed some changes. So anybody who was having problems with the repo, you may want to pull those changes back down. Okay, so this should be deleted out of here, actually. Just delete that. All right, so to recap, what we've done is this needed? I don't even know what this is. This is not needed. Sorry, I have a lot of extraneous stuff in here that I was not aware of. But we split our application into 3 separate services. We have a database now, we have a preprocess, and we have a predict. Right? And these communicate across virtual networks that we defined in our Docker Compose file. And in that Docker Compose file, right, we also defined some environment variables. We also fed in this M file. We used a script to load our data into our database. And just to kind of cap off what I was saying, one reason why you might want to do this, right? Why would you want a database and what is Docker Compose good for? I've used it in the past for, right, like I said, I went over that use case in the beginning, but many times what I'm using this for is to create testing environments. So what you can do is there's tons of different types of containers. An example right now is I'm using Databricks, which is a place in the cloud where you can run Apache Spark, MLflow, but everything's kind of managed for you. One thing that I didn't like was I couldn't test things well because it's based around notebooks. So what I did was I built a local environment using Docker Compose and Docker containers and replicated essentially the Databricks environment utilizing open source containers. And now we can run tests locally as we're developing locally, and we don't have to develop in notebooks in the cloud. And that's really nice, right? And we have a database, we have all this stuff set up. Do I care if that data is persisted? No, it's a test environment. I can spin it up, spin it down, I don't care, right? It's mainly specifically for just pure testing, right? Depositing things, making sure everything communicates correctly, making sure things do what they are supposed to do based on the code that we've written. And because I've replicated the environment from Databricks and tested that, because I obviously needed to test that, but we know that that works, and therefore we don't have to be connected even to the internet to code, to work on our application. We can just work locally, developing our code without worrying about, part of the problem was having to submit jobs, and the testing was just hellacious, to be honest. So anyway, I use it to circle back. The main reason I use Docker Compose these days is to replicate testing environments so that I don't have to test, say, in the cloud. So let's say you're doing a data engineering pipeline. You could have a Docker container locally that is an Airflow Docker container. And you can run your, on a small subset of your data, you can run your Airflow pipeline locally to ensure, just for a sanity check, to make sure it works before you deploy it out to the cloud, right? And you could maybe write some unit tests and things around that. And so I oftentimes use it for that purpose. just purely for testing. And that's a, from what I've seen, that's a very common thing these days. And it's great for before you move to Kubernetes, right? Before you say, I wanted to move, which we will do, move this code to Kubernetes, I could spin up Docker Compose locally and just be like, oh yeah, it works here. Before I like deploy the whole thing to a Kubernetes cluster, just do a quick Docker Compose and make sure that everything's talking to each other and communicating well. Code-wise, I mean, I understand networking is different in Kubernetes than Docker Compose, but nevertheless, testing. Think testing when you think Docker Compose. The next time you're building an application, instead of like deploying it out to the cloud and then being like, well, that didn't work, and then coming back locally, right? Try to build the environment in containers locally and use Docker Compose to network those together. You might find that it's a little bit simpler and a little bit faster. Okay, woo, yikes, Docker Compose. It's a lot, it's a lot. So, you know, soak that in. Definitely look at the Notion template. Again, I'll add those things, the Notion template URL to the README, the M file to the Notion template, and make sure that those are in there so that you don't get stumped. But are there any questions that I can answer about anything that we've gone over or anything that's coming up? Cool. All right. Well, that concludes our session on Docker Compose. If you think of any questions later, feel free to reach out on Slack, either in the container channel or to me directly. Happy to answer questions. And join us next time. We'll be showing dev containers, which are isolated development environments. Really, really great, kind of a use case for containers. The following time, we will be doing Kubernetes. I've never seen that clap before. We'll be doing Kubernetes, and it'll be great. I'm really excited. But other than that, yes, have a great night, and I will talk to you all, I believe, next week.
Thanks, Chris.
Yep, thank you. Enjoy the sunshine if you're in Portland. Cool. See ya.